Question 4. This one is not very easy. Mark is proving the Pythagorean theorem. He draws the right triangle, XKL, that's this fella right here, with the altitude segment JM, that's this here. And altitude goes from a vertex to the opposite side, forming a perpendicular. First, he proves that triangle JKL that's the big one, is similar to triangle MKJ, that's this one here. And he proves that triangle JKL, that's the big one, is similar to triangle MJL. That's this one here. So what that means is all three of those triangles are similar to each other. I don't know if I said congruent or similar, but they're similar. Using the angle-angle criteria. The rest of this proof is shown with some steps missing. So let's check this out. Picture's a little blurry. My apologies for that. So we were given that these are similar triangles. So let me just add some information to this. So this angle is congruent to itself. This angle is congruent to itself. That means in this triangle, that's one arc, this is one arc. That's from those triangles being similar. Part 2 says this is coming from corresponding sides of similar triangles are proportional. So we have JK over LK is equal to MK over JK. That gets a little confusing. I'm not going to put those marks on there. All right, so we got these proportions that are true because we have similar triangles. Then this one here comes from the multiplication property of equality. So here's what's happening. We are multiplying this equation, both sides, by the denominators, LK and JK. In other words, you're cross-multiplying. That gives you this equation here. Do the same thing here. If you cross-multiply, you get this equation here. That's the multiplication property of equality. Now we get to the two steps in the proof that we're missing. Let's look at our choices. We can either use the addition property of equality or the multiplication property of equality. The addition property of equality says we would add these two equations together. Since they are both, since the equations are equal, we could add, let me write down what this means. We could take JK squared equals LK times MK, and then add to that LJ squared plus LK times ML. If you add those together, you're going to get JK squared plus LJ squared equals LK times MK plus LK times ML. Now this statement that you see right here, that is used on this bottom statement, actually on this top statement, on this one, and it's this one. They're identical. If we do the multiplication property of equality, we're multiplying those sides together. It just doesn't make a lot of sense to me. So let's just assume it's addition and see what happens. So that we're saying that either this is true or this is true, and that's the same statement. The next statement after that's a distributive property. In other words, factor out the greatest common factor. What's the GCF of this? It is LK. If you factor that out to the front, you're left with MK plus ML. So this makes sense to me. This one here, if you factor out LK, you shouldn't be left with LK plus LK. This is just a ridiculous statement. So let's assume that this is the answer, A, and let's see if the rest of the proof would follow from that. If it does, let's not even examine these multiplication ones on the right. This says the segment addition postulate, which is independent of this. So once you know that fact, notice how this is the same as this. So you can substitute one for the other, replace it with an LK. If you replace this with an LK, you get LK times LK, which is LK squared. So A is the best option for this. This is by no means an easy proof.